This isn't really example one. I called it objective one. Our first objective today is we're going to translate verbal expressions into algebraic expressions. Then we're going to solve decimal sentence problems. So these are verbal expressions. And translation of math into algebra, or translation of words into algebra, is similar to translating a Spanish into an English phrase. Different words have different meanings, okay? And it's our job to take the words they have and get the proper meaning involved. The operations that are going to be dealt with in these verbal expressions are going to be addition, subtraction, multiplication, division, but there will also be the use of parentheses occasionally, and that tends to be the part that tends to be more challenging for students at the beginning Algebra 1 level of when do I use parentheses, when don't I use parentheses. I'm going to try and get that across to you today. There's specific things you can look for that let you know, hey, parentheses are necessary. And it's not going to be like a little flashing light on the problem saying, hey, parentheses are necessary on this one, but hopefully it'll be that obvious to you at some point that you'll see it say, oh yeah, I need parentheses for this, or no, I don't need parentheses for that. The first few are going to be pretty straightforward, just basic translation of the basic operations. So the sum of, when you see the words the sum of, you're looking for the word and, that's where the plus sign goes because sum means to add. And then what we're adding is a number and 7. Alright, now I think we can all agree that 7 is a number, right? And it says we're adding a number and 7. 5 is a number, 10 is a number, negative 2 is a number, 1/2 is a number. When you see the words a number, the number, it represents something we don't know. So algebraically that translates to we're adding a number that we don't know and 7. You can use the letter X to represent the unknown. I like to use and, sometimes X. Those are my favorites. Y is pretty popular. Don't use O. O looks like 0.
Or B.
Lowercase L looks like a 1. B's can look like 6s if you do a lowercase b and you're not very good about it. You know, the 6B, they look close. So anyway. Letters that look like numbers are probably good to avoid. S's a lot of times look like 5s depending on how neat you write. So if you're allowed to pick a letter yourself, I recommend picking a letter like X or N or Y, things with straight lines and that don't look like numbers. 7 less than a number. Now less than represents subtraction, but it's very important with subtraction we get the order correct. Alright? There's 7 minus a number. There's the difference of 7 and a number. There's 7 less than a number. Those are 3 ways that can show subtraction of a number and 7. But the first 2 have a different order than the last one. Alright, so when you see the words less than, that's subtract in reverse order. Alright, so when you see something less than something, you put the second thing minus the first thing. And again, subtraction, the order of subtraction is very important. If you get the subtraction order wrong, you get the wrong sign on your answer. Alright, so be careful with subtraction. Addition's not as worrisome as far as that's concerned. N plus 7 and 7 plus n mean the exact same thing. But n minus 7 and 7 minus n mean something different. So when you see less than, it is subtract, but reverse order, second thing minus first thing for that specific one. If it said 7 minus a number, that's 7 minus n. If it says the difference of 7 and a number, that's 7 minus n. But again, 7 less than a number, n minus 7. Alright, decreased by is another subtraction. That's in regular order. Alright, so we're subtracting the opposite of a number and 5. Alright? We already know that a number would be n or x or some letter, right? The opposite of anything means to change its sign. So, if n is a number, minus n is the opposite of a number. Decreased by means subtract, and then we're subtracting 5. So minus n minus 5. Alright, now take a look at this one. The sum of, just like the first one was the sum of, we're looking for the word and. So we're adding the opposite of a number and negative 5. So what does the opposite of a number look like?
Negative.
Negative what?
N.
Negative n is the opposite of a number. We're adding that to negative 5. N plus negative 5. Does everybody see that negative n plus negative 5 is equivalent to negative n plus 5?
Yeah.
Or sorry, minus 5, sorry, this one. Plus negative, same as minus. These are exactly the same thing. There's two ways using different words to represent the exact same thing. Okay? If you do add a negative, you're welcome to write it as minus 5 instead of plus negative 5. That's fine. But again, direct translation of the words into an expression would be that. The simplified version would be what we have above it, negative n minus 5. Okay, next one says the product of. What does product of mean? To multiply. And again, where and is, anytime it's the sum of, the difference of, the product of, the quotient of, the operation of, look for the word and to find out where the operation goes. So we're multiplying twice a number and 8. All right, what does twice mean?
Times 2.
Times 2. So twice a number is n, twice a number is 2n. And we're multiplying that times 8. So that's the direct translation, 2n times 8, product of twice a number and 8. I could, if I want to, simplify that out to something better. 2n times 8 is the same as 16n. So again, sometimes you'll translate these words. The expression you have is not in simplified form. If you simplify it, it makes the problem easier to look at. Next one, we got sum of again. There's and, right? So that's where the plus sign goes. Twice a number is
2n.
2 times n. And we're going to be adding negative 5. So notice I put 2n minus 5. If I can mentally see plus negative and remember that just means minus, I can write it just like that. If you write 2n plus negative 5, you're not wrong. Okay, but just keep that in mind that if you recognize it as for what it is, that's fine. If it said the difference of twice the number and negative 5, minus 5 is plus 5 then. All right, so difference means subtract, but subtract a negative becomes addition. Sum means add, but add a negative means subtraction. So you can go ahead and modify that if you wish. Okay, now here's where some parentheses start showing up. And again, there's nothing blinking on the board saying, hey, parentheses show up on this one. I have the vision of these problems. I've seen these enough. I can start recognizing the wording structure that creates parentheses. This says 5 times. What does times mean? Multiply. 5 times the sum. All right. If I'm doing something times a sum or a difference or a difference is going to be a binomial. All right, that's what sums and differences are. Binomials, two objects. I can't multiply one thing times two things unless parentheses are there. So, when I see 5 times the sum, I immediately go 5 parentheses. When you put a number followed by parentheses, that's an understood multiplication going on here. 5 parentheses is 5 times. And again, the fact that it says the sum means that I'm going to have more than one object being multiplied by 5. The parentheses are necessary there. Just like before, when I see the words the sum of, I'm curious where the and sign is, which is right here. That's where the plus sign goes, right? So twice a number would be 2n, plus negative 5 is going to be minus 5. All right, so again, parentheses were necessary there because 5 times the sum. It's very obvious. That's the most obvious one that happens in this class. 5 times the sum, 5 times the difference. Parentheses are always necessary in that situation. Okay, look at the next one down. 6 times the sum. So again, once I see 6 times the sum, 6 parentheses. All right, sum of, here's the word and. That's where the plus sign goes. So we're adding twice the opposite of a number and negative 8. All right. First of all, a number would be n, and an opposite of a number would be negative n. 2 times negative n is?
Positive.
2 times negative n is?
Negative n.
All right. So twice is 2 times, opposite of a number negative n. 2 times negative n is equal to negative 2n. So all those words there translates just to negative 2n. Sum means add, plus negative 8 is minus 8. For me personally, I prefer to go that route as opposed to the plus negative like this and this one. Again, if you like that, that's fine. Hopefully you're getting to the point where the minus 5 is more comfortable to you than plus and negative. This is just too many symbols written on your paper in my opinion. So I prefer to go straight to plus negative 8 in my head. Mentally means minus 8. Okay, you got the words the product of, right? product of 7 and the sum of a number and 10. All right, now take a look at this. We're multiplying 7 times the sum. Okay, a little bit wordier there to say the same thought as the last two, but we're multiplying, that's product of multiplying 7 times the sum. So 7 parentheses, the sum of a number and 10, that'd be n plus 10. So again, it's not just 7 times the number, it's 7 times the sum of the number and 10. So the sum of the number and 10 go in parentheses in order to multiply the entire thing by 7. Here's one other way that parentheses can show up that has not been discussed yet. Kind of the same idea, it's just structured differently, so maybe this is a way they might try and trick you up. I promise you, these ones here are the ones that are most commonly seen in this class. Number times the sum, number times the difference. All right, but the sum of 3 times a number and negative 4. All right, so let's start there. 3 times a number and negative 4. Again, add this plus negative 4 is the same as minus 4. Then it says multiplied by 5. It's implying not that negative 4 is being multiplied by 5, but this entire expression here is being multiplied by 5. The entire expression is a binomial, so the 5 has to go outside the parentheses to show that it's being multiplied by the entire expression. If you choose to put a number on the right-hand side like I did there, put a multiplication symbol. If you put parentheses 5, I know what you're talking about, but it's just better math to have that multiplication symbol. Number followed by parentheses is more appropriate to leave the times off. That's more appropriate to keep the times on. Finally, the sum of negative 10 and 6 times the opposite of a number. So look at this last one here. The sum of, we're adding this and this. All right? So the first thing we're adding is negative 10, and we're adding that to 6 times the opposite of a number. So, negative 10, and what's 6 times the opposite of a number look like?
Negative.
Negative what?
Negative 6n.
Negative 6n, right? N is the number, minus n makes it opposite, and 6 times that makes negative 6 times n. Typically minus signs go first, and then number, then letter. So, n, make it negative, then times 6, the 6 goes in front of the minus sign. So negative 6n is what that is. Plus negative 6n is minus 6n. There is multiplication happening in this one, but it's not 6 times the sum. It's just 6 times the opposite of the number that's being added to negative 10. So there's no parentheses necessary in the last one. And again, that tends to be the most challenging part of these problems. When are parentheses necessary? Some of the problems that you get in your lesson in the next couple of homework assignments are going to say, translate the words into an algebraic expression. All right? I'm looking for this type of answer. If you want to use x instead of n, that's fine. Some of you guys, your y's look like 4s, so maybe even shy away from y, but x's look like x's, n's look like n's. Usually p's look like p's. Unless you got really bad handwriting, it might look like 9.
What about a Z?
Z, as long as you put a line through it, otherwise it might look like a 2.
Or a 7?
Or,
Yeah, 7 if you don't finish your Z off all the way, maybe.
or do your 2 difference.
So, anyway. So just make sure that if you look at it, you recognize for what it is. If you want to take your time to write the letters more neatly, to very clearly make them what they're supposed to be, that'd be fine. Use uppercase letters if you want to. A capital B is going to look like a B, not a 6. Okay, so again, just as long as your letter looks like a letter, you're in good shape.
What about a Q?
What about a Q?